Hey everyone, and welcome to this explainer. Okay, today we are stepping right into the high-stakes, super complex world of embedded systems development. If you're building a smart device, maybe some critical industrial equipment, or an edge appliance, you already know the software powering it is just as vital as the physical hardware itself. And when we talk operating systems, there's usually one undisputed heavyweight champ that comes to mind, right? Linux. But as we're going to see, simply choosing Linux is just the very beginning of a much deeper conversation.
So you've got to ask yourself this foundational question. Which Linux is actually right for your embedded device? I mean, Linux is the default for most developers for a reason. It's incredibly powerful, but its biggest strength is honestly its biggest challenge too. It comes in just countless flavors. Validating your choice to use Linux, that's the easy part. The real dilemma is deciding exactly how you're going to source and maintain it over the entire lifespan of your product.
Okay, let's dive into this. Here is our roadmap for today. We're going to hit 5 key areas. 1. The embedded Linux dilemma. 2. The roll-your-own trap. 3. The commercial Linux solution. 4. Accelerating time to market. And finally 5. Security and legal compliance.
All right, jumping right into Section 1, the embedded Linux dilemma. And spoiler alert, one size definitely does not fit all.
Look, there is a massive contrast in requirements here. We all know and love enterprise Linux distributions, your Red Hats, your Ubuntus. They are fantastic for general-purpose IT, servers, multi-user stuff. They have this kind of one-size-fits-most vibe with a 3 to 5 year support horizon. But embedded designs? Totally different beast. They live in highly constrained environments, they need a tiny footprint, bulletproof reliability, and support needs that routinely stretch to 10 years or more. Enterprise Linux just literally wasn't built for those strict, long-term conditions.
Think about mission-critical environments for a second. Factory automation, medical devices, telecom infrastructure. In these scenarios, you absolutely need a hyper-focused OS. You cannot afford the bloat, or worse, the forced update cycles of an enterprise system when a machine is running a literal factory floor. You need an OS tuned down to the exact system on a chip that you're using.
Which brings us to Section 2, the roll-your-own trap. Or, as I like to call it, the iceberg illusion.
So, in response to enterprise limitations, a lot of teams say, hey, we'll just fork an existing community distribution and strip it down. They roll their own Linux. But I want to pose a slightly uncomfortable question to you. Do you really want to support your own unique Linux distribution? Because a lot of newcomers don't realize that every roll-your-own setup essentially becomes a totally unique, custom, in-house OS. You might think you have the open-source community as a safety net, but they know absolutely nothing about the unique fork you just created.
And here is the brutal reality of the math behind that choice. The initial upfront costs, they look pretty low. It's just the tip of the iceberg. Say you're building a telecom device. Porting and QA might run you $600,000 up front. Not terrible, but then bam, you're hit with yearly maintenance, annual security assessments, and export compliance. Over 5 years, the total cost for that custom roll-your-own Linux balloons to roughly $3 million. And as community support dries up for older kernel versions, that massive burden falls 100% on your internal engineering team.
So, how do we avoid sinking millions into maintenance? Let's pivot to Section 3, the commercial Linux solution, scale and support. Instead of struggling completely alone, you can tap into massive economies of scale with commercial vendors. Take the Yocto project, which is the absolute gold standard for embedded Linux. A commercial vendor like Wind River is actually the largest single contributor, driving over 18% of the commits. So you're not just buying software, you're partnering with the people who literally drive the core standards.
So the crucial point here is open embedded. It's this best-in-class cross-compile environment acting as the engine under the hood. Instead of a bloated enterprise blob, it gives you a compact core. It lets you create highly customized builds that perfectly fit your project. But here's the magic. Those builds are sourced from the same code and are meticulously monitored and patched by a dedicated commercial team. You basically get the flexibility of rolling your own, without any of the heavy lifting.
All right, moving beyond just cost savings, let's talk about Section 4, accelerating time to market, speed, and architecture. It all starts with the BSP, the board support package. Basically, this is the software layer. Actually, scratch that. Think of it as a massive bridge that contains the exact drivers letting Linux talk to your specific hardware. Trying to build these hardware support packages from scratch is a notoriously slow, painful nightmare. A commercial BSP is a huge shortcut that's already polished and tailored to your exact system.
By leveraging one of these commercial BSPs, you instantly unlock 4 major wins. Blazing speed to get started, incredibly deep hardware expertise, vendor economies of scale, and most importantly, fully supported updates. Commercial vendors have libraries with literally thousands of ready-to-go BSPs for almost every popular processor out there. No reinventing the wheel required.
And this is a real game changer. Commercial embedded Linux is now bringing modern architecture right to the edge. Up until very recently, container tech like Docker and Kubernetes was strictly for enterprise data centers, way too heavy for embedded devices. But today, modern solutions include pre-integrated, embedded optimized support for these tools. Your edge appliances can finally get the perks of code reusability, platform independence, and wildly efficient maintenance.
Okay, we've arrived at our final and honestly most critical section. Section 5, Security and Legal Compliance, the Hidden Liabilities. And this brilliantly illustrates the terrifying reality of security over time. There is a massive widening gap between the flood of new security alerts and the actual vulnerabilities that get fixed in older, unsupported releases. The older your custom device gets, the wider that gap blows open. Fire and forget deployments? Yeah, those days are totally over. If your device is connected, it's vulnerable. You absolutely need proactive security monitoring and patches at scale to survive.
Then there's the whole legal minefield. Gartner points out that 50% of companies are going to face challenges just from lacking an open-source policy. Here's a massive trap a lot of folks fall into. Shipping a physical product that runs Linux isn't like using it on a laptop in your office. It's legally considered redistribution under licenses like the GPL. You are suddenly on the hook to document and fulfill the obligations of potentially millions of lines of code.
And if you're thinking, hey, my hardware vendor has my back, no way. Just listen to this real warranty text from Texas Instruments. They explicitly state customers are responsible for their applications and TI assumes zero liability for your product design. The hardware guys supply the chips, that's it. All the legal compliance and design risk lands 100% squarely on your shoulders.
That liability even extends to international export laws, which heavily regulate cryptography. If you're exporting globally, you have to thoroughly document and disclose the crypto inside your open-source software. When your device uses thousands of components, doing a manual search for cryptography is practically impossible. You absolutely have to have automated tools paired with human encryption expertise to filter out the noise. And that's exactly the kind of service premium commercial vendors just provide out of the box. So what does this all mean? It leaves us with this final, incredibly provocative question. In today's hyper-competitive market, is your engineer's time better spent innovating and building amazing products that actually drive revenue? Or are you going to tie up your best talent babysitting a frozen, risky branch of a custom OS? It really comes down to the illusion of a free initial setup versus the proven speed, security, and long-term savings of a commercial foundation. Thank you so much for joining me for this explainer, and I hope this gives you the exact clarity you need before tackling your next big embedded project.